Once there was a song yearned to be sung. It was a spinning song about the king of rock and roll. The king was first a young prince, the prince was the best. With his black jelly hair, he crashed onto a stage in Vegas. The king had a queen, the queen's hair was a stairway. She tended the castle garden, and in the garden planted a tree. The garden tree was a stairway, it was 16 branches high. On the top branch was a nest, sing the high cloudy nest. In the nest there was a bird, the bird had a wing, the wing had a feather, spin the feather and sing the wind. The king in time died, the queen's heart broke like a vow, and the tree returned to the earth with the nest and the bird. But the feather spun upward, upward and upward, spinning all the weather vanes, and you're sitting at the kitchen table, listening to the radio. And I love you, 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 and I love you. The bright horses are broken free from the fields. They are horses of love, their manes full of fire. They are parting the cities, those bright burning horses. And everyone is hiding one makes a sound, and I'm by your side and I'm holding your hand. Ride horses of wonder springing from your burning hand. And everyone has a heart and it's calling for something. And we're all so sick and tired of seeing things as they are. The horses are just horses. Since pity is fled, and tears and sighs and wounds, my weary days, all joys and deep hark, you shadows that in darkest way, let you feel not the
soll ich dich empfangen? Und wie begegne ich dir? O alle Welt verlangen. O meine Seele mir selbst die Fackel bei. Lass dich ergötzen, mir kund und Wissens dein Zion streut ihr Palmen und grüne Zweige hin, und ich soll dir im Psalmen ermuntern meinen Sinn. Dein Herz soll dir dienen, ihm steht Lob und Preis, und deinem Namen dienen, so gut es kann und weiß. Ich lag in schweren Wandern. Du kommst und machst mich los. Ich stand in Spott und Schande. Du kommst und machst mich groß und hebst mich hoch zu Ehren und schenkst mir großes Gut, dass ich nicht lässt verzehren, wie irdisch leicht und
Hello, welcome to this evening concert and keynote at Live Interfaces. We look forward to a comprehensive concert program here with Francesca Baumann, Trond Engum and Karl Håkon Vådland, Federico Visi, and Daniel Formo. We will have some breaks in between the different performances and happenings, so that you can also go out and refresh your drinks if you have an urge to do that. And now it is my great pleasure. Let me see. There's something I have to get right to welcome Rebecca Fiebrink, who is a reader in the Creative Computing Institute at the University of the Arts in London. And the reason why I had to sort of get this right is because she is progressing so fast in the world. So she had changed her jobs since I last noted her occupation. So Rebecca has been an inspiring figure on the scene of machine learning and music for many years, and we look forward to your keynote. So please welcome Rebecca Fiebrink.
Thank you. Excellent. Great to see everybody tonight. I want to start by thanking the organizers for inviting me, and especially for accommodating me with my wife and 5-month-old kid who are here. Would not have been able to come without that. So really appreciate that. So let's dive in. So today I want to talk about a lot of the research that I've been doing over the last 10 years, or even a little bit more, largely around creative uses of machine learning. And given that this is the Live Interfaces conference, I think a lot of people here are going to immediately understand and be receptive to some of the ways that I think about machine learning, not necessarily just as a tool, but sometimes as an interface or even an instrument, and sometimes an instrument for building other instruments or other interfaces. So I'm happy to talk about that, and we should have time at the end for questions as well. Now, I know machine learning is everywhere right now, but people have different levels of knowledge about it, and I'm not going to assume any knowledge, so I'm going to start out with a really quick machine learning basics part of my talk, and then after about 5 minutes of that, I'll dive into the rest of the stuff. So I'm going to talk about creative interactions with machine learning, but also creating interactions with machine learning. Okay, so machine learning, essentially, if you don't know anything about it, or you think you know a little bit about it, throw away everything that you hear from, Elon Musk and the popular media. It's not magic. It's not necessarily intelligent. We can think about it most simply as just a set of algorithmic tools for finding patterns in data and working with those patterns. So if we were say in a standard introductory computer science class, we might talk about machine learning in one of its more conventional applications, which of course is to make money. And there's lots of money to be made with machine learning right now. And so we might say, all right, imagine you have an online store and you want to make money with machine learning. One of the things that you might do is collect data about everybody who comes to your online shop, demographic information about what else they've done on the web recently. And you could use a machine learning algorithm to find patterns in that data and maybe detect that some of your customers are similar to each other and other of your customers are similar to each other, but those groups might be distinct. And furthermore, we could use a slightly different type of machine learning algorithm to start making predictions from the patterns that we observe. So we might look at what people in the past have bought in your online shop and also pair that with the demographic and other purchase history information we have, and we might start to see some patterns emerge that the customers on the left all buy a particular album in your online music shop, and the customers on the right all have bought another album in your online music shop. And so that you could use this data, give it to a machine learning algorithm, and say, hey, when I get a new customer who arrives, and I know a little bit of information about them because, of course, they're being tracked, everything they do on the web, I could predict what that person is likely to buy and maybe highlight, hey, I've got a special on this particular album. And of course, one of the other applications of machine learning that's been getting a lot of attention over the last few years has been generation. So generating new content. And this is exciting. There's still plenty of money to be made here, but it's not as clear a fit to the really conventional types of applications that I was just talking about. And in fact, it doesn't even necessarily make sense to talk about generating new customers unless you're also generating money for those customers to spend in your store. It is much more interesting when we start talking about media, though. So all of you have probably seen examples of this. We can give, say, just images of cats now to a generative algorithm, like a GAN, and we can generate many new images of cats. So we're never going to run out of pictures of cats for the internet. And of course, we could do this with other content. And this has been done maybe most infamously in a portrait created by a GAN, a generative adversarial network, that's sold at Christie's for some insane amount of money. And essentially, this is just an off-the-shelf standard algorithm that's been developed in the last few years, applied to a bunch of portraits. And the creators said, all right, let's try to generate some new portraits. And here's one of them that came out. And of course, you could do this with other types of media as well. This is WaveNet. This is something that came out of Google and DeepMind in 2016. So this is actually quite old now, but it's still close to the state of the art. And we can do this with voice. We could also do this with music. And so this is a generative algorithm trained on a corpus of piano music. And what makes this really interesting is that this isn't coming from MIDI. This has actually been trained on recorded piano. And in 2016, when this was absolute state of the art, this is the type of sound that was generated. So here we go. All right, and so you can see it sounds like piano music. Might not be exactly like the kind of music that appeared on those classical albums, but it's not too far off. And these algorithms are getting better and better. And of course, we could do this with other media, including text. If you're not familiar with Janelle Shane's work, she has a blog at aiweirdness.com, and you should definitely check it out. And she just throws lots of different types of content, much of it text, at these generative algorithms and shows you what she gets and talks about why the algorithm produces different results. And so this is one of my favorites. And of course, we're in Norway, so I thought it'd be cool to do metal band names. And these are all, not real bands, but some of them are, I would listen certainly to Dragon Red of Blood or Death Crack, right? These sound really cool. And then we have some weird stuff like Imbumblius and, of course, Chaos Warge Le Plague, which maybe are questionable. But she's actually also got a book out right now. If anybody's interested in learning more about generative algorithms, she has a very approachable and humorous take on it. So I'll leave that there. So this is maybe not state of the art as of March 2020, because this is a very fast changing field, but this gives you an overview of what a lot of people are doing with machine learning in creative fields, and certainly the sorts of machine learning that gets talked about a lot in the popular press. And this has led to me being asked over and over again a number of questions that make me really sad by people in the media, by students, and so on. And so the first question that makes me sad is when people see this work and say, but are machines really capable of making real art? This is, I'm not so sure about this. Or people say, isn't it terrible? There's going to be no more jobs left for creative people. And of course, this first question, it depends on your definition of art. Hopefully, machine learning can expand our definition of art rather than cause us to argue about things that, don't matter so much, like these questions. And in my work, especially, I'm interested in not necessarily taking the place of creative human work, but augmenting it, expanding it, challenging ideas of what we as people might do and how we might use computers. So that's what I'm going to talk about. But again, a lot of the popular discourse around machine learning is very much assuming that machine learning is going to lead us to some sort of, dystopian 21st century Clippy who says, it looks like you're trying to make some art. I'll just do it for you. But as I'm hopefully going to get you thinking, there's a lot more that we might explore in this space, and some of it is actually not just rewarding and useful, but playful and quite lovely. All right, so the questions that I asked in my work look something like this. How might people actually use machine learning within their own creative practices, whatever that might be. Most of my work has been historically in music, but I've worked with artists, I've worked with game designers, and I've had students go on to do work with a lot of other fields as well. And I'm interested in how machine learning might expand people's creative practices. And if we want to answer these questions, we can go back to that definition of machine learning that I gave you at the beginning of the talk about finding patterns, making predictions, generating new data or new content. And so we can just ask the question, well, when and why might it be creatively useful to do these things? And furthermore, something that is very important to me is to ask, how might these interactions be structured? How do we actually give real people access to these tools in a way that's meaningful to them for a variety of practices? And how can we enable creators to use machine learning effectively, particularly when these might not be people who have PhDs in computer science or want to go detour and get a PhD in computer science in order to do something useful? All right, so one way in to answering these questions is to think about what types of data are useful or are interesting or are just present in different types of creative practice. And when you start looking for such data, you actually, I think, realize that it's everywhere. You can treat so many things as fruitful sources of data that you might throw to one of these types of machine learning algorithms. So not only do we have large collections of images and sounds and text that we might mine and generate new content, we have things like the traces that an artist might leave behind in software as they use Photoshop or as they use a digital audio workstation. We have data that we could collect from performers as they move on stage. We have social media data. We have, again, pretty much anything you can imagine now is, captured in a computer, or somebody's trying to capture it digitally to monetize it, but maybe instead of monetizing it, we could turn it into creative sources. All right. And of course, I'm interested in saying, well, how could creators benefit from this data? Not necessarily how do we make money from it, but what would an artist do with this data? What would a dancer do with this data? And so on. So as I mentioned, I've began this line of work primarily working with musicians, and that was in about 2008. And at that time, I was working with composers and musicians who were building musical instruments, very much in the NIME community, and people were working with a lot of sensors, like you see on the screen, things like sensors for not just video and audio, but Connect, muscle data, DIY sensors with Arduino, and so on. And I noticed, that this is data. We can apply machine learning to this. However, not many people were doing that at that moment, and I'll come back to that. Now, if you've ever built a system, an interactive system with some of these types of inputs, you may have noticed that getting data, especially now in 2020, but increasingly over the last 15 years, this has been getting easier and easier because we've got a lot of these off-the-shelf sensors and user-friendly DIY toolkits that give us this data almost instantly with little effort. However, as soon as you want to do something useful with that data, you want to interpret it and make a decision about what somebody is doing maybe on the other end of that sensor, or you want to map that to control or interaction with music or sound or lights or visuals or something else, then that often becomes difficult and annoying, right? And that's true even if you're an expert programmer, even if you have a lot of expertise in signal processing, this is just a really hard problem, right? Many of you, again, I'm sure have a lot of experience with this. But of course, if we think about this problem of interpretation or mapping, we can use the same machine learning infrastructure that we were using to make predictions to sell people things. And so this is where I started this work, again, in about 2008. So instead of saying, well, here's some demographic information and we're going to predict what this person might like to buy, we could say, well, here's some sensor information from a camera or something worn on the body, and we can predict or really just decide what kind of music or sound synthesis should the computer make at this moment in response to that performer action. Or we could make a machine listening system where we've got notes coming in, some sort of music information retrieval happening. So we get information in a usable form about what that music is. And then we can predict or really decide how we drive some interactive visuals. Or in the gaming space, we might have somebody speaking words or doing physical actions, and then use that to decide how we control the game avatar, and so on, right? All sorts of interesting interactive problems fit into this very simple framework. Right. And as I mentioned, when I started doing this work, this was a clear fit for so many of the interaction design challenges that I saw people trying to meet in their work. And yet machine learning was barely used. Now, machine learning wasn't new to this space. Certainly in music, Michael Lee and David Wessel were doing experiments with neural networks in the early 90s. But 20 years later, for the most part, people weren't using machine learning very much, and those who were had PhDs in computer science and were writing all their own infrastructure for it. So I became really interested in how we could support musicians and artists and other creative people in using these types of algorithms to build the types of systems I just suggested on the previous slides. And the solution I came up with was something called Wekinator. Some of you may have used it. And I initially thought about this, and I guess I still think about this as really a meta instrument. It's a user-friendly, interactive, engaging, creative tool, hopefully, for building sensor-based interactions like the one you see here. And so essentially, this is a modular system. It doesn't know anything about music or gesture. It just gets data in via open sound control and sends open sound control data out, if that's meaningful to you. If that's not, ignore it. But we could have some kind of sensor data coming into a machine learning model that does this prediction, and then we send that data out from that model to control sound or animation or something else. And again, ideally, I wanted to build something where users didn't have to be a programmer, didn't have to know much about machine learning, and not only could run these predictive models, but could build them themselves from scratch with their own data. And so I'm going to give you a demo in a second, but I want to show you first what's happening in the demo to make it absolutely clear. So these types of machine learning algorithms that I'm using here, they build models from examples. In this case, if I want to build a gesturally controlled instrument, I can give it some examples of gesture sensed with whatever sensors I'm using and the corresponding sound I'd like that instrument to make. And so I throw a few examples into this algorithm. Doesn't need to be many, and that's something interesting in this space, which we can talk about. And then this algorithm builds me a model. And I can show some new data to that model. I can maybe move my hand around and see what kind of sound comes out. And if I like it, great, I perform with that model. It's embedded into the software that I'm performing with. But if I don't like it, I can also go back and change the data. So I'm maybe giving it new data and saying, well, when I tilt my hand, I also want this sound, and that algorithm hopefully will be able to build me a better model that captures that new information. And this is generally in the human-computer interaction space called interactive machine learning, where it's not just that we collect a data set, we take a ground truth data set from the internet somewhere, and we try to build a good model, and then we're done. This is very much a case where the data set might be malleable. The data set might be something that somebody creates on the fly. All right, so with that, I'll give you a couple demos. And the first demo I'm going to show you uses, what do I want to do? Yeah, I'm going to do, if I can find this. This is going to use the world's worst computer vision system. This is just taking my webcam and it's downsampling it to a 10 by 10 matrix. And so you can see that there's stuff happening when I move around in front of the camera, but it's, not super informative. I consider myself to be a very good programmer, but I do not want to be the person who writes the code to parse these 100 values and say what's happening in front of the camera, right? And I assume you don't either. So we're going to use Wekinator instead, and we're going to use machine learning to build a very simple instrument where this is the input control to that instrument. And the output here, I'm going to control a very simple drum machine. And so here I'm going to tell Wekinator to take these 100 values in and send one value out to control this drum machine. And I don't have a data set that I'm starting with. I'm starting from scratch. So I'm going to start giving some examples of me standing here and saying, this is sound number 1. And I'm going to give it some examples of me not standing there. And this is sound number 2. So, all right, now I'm going to tell my machine learning algorithm to build a model, and I'm going to run that model and play with it. All right, it seems to be doing pretty well. I can try to find a spot where it makes a mistake, and I would say this is a mistake. So I can give it more examples of me actually here and say this is also sound number 1. and I can rebuild that model on the fly and test it out again. Ah, interesting. So for some reason, it's now making another mistake over here. Let's give it some more data. Okay, so that seems to be a bit better. And maybe I save that and play with it, or I can make it more complicated and say I want to give it another sound with my hand. Okay, so quick and easy, not an entirely, musically impressive system, but certainly worth the 30 seconds that I took to build it. It was pretty fun, and much faster than if you'd programmed that as a programmer. The second demo I want to show you is a better representation of how musicians have tended to use the system. Again, the demo you just saw was kind of fun. It makes simple triggering of sounds a little bit more interesting to watch. And of course, if I were a better dancer, I could make it really visually fascinating, probably, or at least a little bit more fun. However, the music that you can make with that approach is essentially the same kind of music that you could make if you had a MIDI controller and you were just pressing a couple buttons. So the second demo, once things load up here, shows you a different way of using machine learning. This is a more complicated system, but it allows us to actually make music that we probably couldn't make with a simpler controller. And so for this demo, I'm going to use Leap Motion as my input. So I'm just getting data about, in this case, where my fingertip positions are in space, and I'm getting an XYZ coordinate for each of those fingertips. And I'm going to build an instrument that allows me to play this physical model called the blowtar. And blowtar is really nice because it has a really rich, wide set of sounds. There's some really great musical possibilities here if you're into the kind of sounds that I like. And so I'll give you a preview of some of these sounds. Oops. So there's a fluty sound. Okay, so all these different sounds are here controlled just by changing 9 parameter values, right? So building an instrument with blowtar and Leap Motion actually requires you, in the simplest case, to create a mapping function where you have 15 values coming in and you're trying to control 9 values going out. And of course, you probably want to make this mapping something that gives you access to interesting sounds, that allows you to move in a physically feasible and comfortable way that doesn't make you look silly when you're doing it, and all sorts of other constraints that might be specific to your own practice or the piece that you're making or so on. And of course, that's a really hard problem. Again, even if you're an expert programmer, that's going to take you a while and it might be pretty annoying to do. So we're going to use machine learning, and here we're going to use regression. And we've got 9 values or 15 values coming from the Leap Motion, controlling 9 blowtar values. And I'm going to start by finding a sound that I like. And let's put this sound right here. And I'm just going to give it some examples and say I want that sound when my hand is here. And maybe I want a higher sound when my hand is up here. And I can build a model or a set of models and run them. And I have easy control. Still not super musically interesting though, right? I could do this with a slider on screen. I could, sort of musical blowtar theremin. But it starts getting much more interesting when I choose a very different sound. And maybe here I want to make sort of a claw shape with my hand, and I'll put that over here. And I'll say, now I want this sound to happen in this part of the input space. So I'm going to rebuild my model and run it. All right, so you get the idea there. Suddenly, with just essentially 3 types of examples, I've built a mapping that captures the information that I've given it. It's making those sounds in the places where I gave the examples, but it's giving me some interesting stuff in between. It's giving me some stuff outside of that, and it's suddenly very fun to explore. And again, I could, if I like this, I could start practicing it. I could wrap it up, save it, use it in performance, or I could keep doing what I've been doing on stage and keep adding new sounds to new places in this input space and see what happens and evolve an instrument or a controller over time, maybe over 10 minutes, maybe over 5 years. I've had users really at both ends of that spectrum and beyond, actually. All right, so let's go back to the slides here. Here we go. All right, so now in this part of my talk, this is sort of the research highlights bit. I want to talk about some of the questions that I motivated at the beginning. So how can machine learning support and expand people's creative practices? I don't have a final answer to this, certainly, but I've really explored this deeply in a lot of work with Wekinator and associated projects. So I'll walk you through that. And specifically, I'll try to highlight what human machine learning creative interactions might look like. Hopefully, again, revisit this idea of interaction design as sort of instrument, certainly as a playful, fun, creative process in itself. And what consequences do these interactions have for creative practice? So let's run through this a bit. Again, this is not from a specific project, but these are reflections from the last 10 years or so and the last 25,000 users or something like that last time I checked. Okay, so the first point is, just relates to the original motivation I had for this work. And I think it's interesting. It's really that machine learning, yes, it can help us unlock the interactive potential of sensors. It can help us build new musical instruments more easily, build new types of instruments, and build other types of fun interactions. So I'll show you some highlights of some of my favorite pieces that people have made. This is from a work by Anne Heggie. This is one of the first Wekinator users, and she made this really beautiful piece in which performers are using PlayStation golf game controllers to make this really lovely music. So here we go. Right. And one of the reasons I really love this piece is that there's this clear visual language. The performers are moving in something that's very much like a yoga sun salutation. It's very graceful. And of course, to create this instrument, Anne had a very specific idea in mind of how she wanted people to move and how she wanted the sound to smoothly evolve from that. And of course, that's a sort of thing that can be really hard to do as a programmer. But if you're building a system by giving examples of movement, and in her case, saying, this is how I want to move as the sound evolves in this way, this becomes a much more tractable problem. This is another very early user of Wekinator. This is Michelle Nagai, and she built this wonderful instrument out of a piece of tree bark that she found on the side of the road. She put a bunch of light sensors in this tree bark, and she plays it by standing on stage under a spotlight and casting shadows over those light sensors with her hands, turning away and toward the light, and so on. And so this is an example of an instrument. I think there are 25 light sensors here. This suddenly starts to become really hard to build by programming because you just have so much data. But
basically,
let me turn that down a little bit.
And it's comparing it to examples that I've given it in the past of relationships between certain data and certain gesture and a certain sound. So if I train the machine learning software that when I wrap my arms around the instrument and the sensors register less light, it makes a particular kind of sound, and then full light, it makes a different kind of sound. So I give it all these examples in the training process, and then I run it and I see what happens. And it takes the data that's coming in and says, oh, that looks just like the data, or that's similar to the data that she has when she wants this sound. So it sends that message to my sound processor, and the computer outputs that sound. So it's just another way, basically, of mapping gesture to sound.
And then
Basically,
the third video I'm going to show you is a snip from Letitia Tsunami. She's been building an instrument called Spring Spire for 7 years now with Wekinator. And this is a set of springs stretched over a metal frame. And the data she's getting from these springs is actually coming from audio pickups. But you don't hear the audio of the springs at all. She's just extracting data from those springs using a set of bandpass filters. And then through Wekinator controlling a very elaborate set of max patches. And so this is a video from a much earlier version of her instrument, but it's a nice piece. So I'll play it for you here. So you can find each of these on full versions are on YouTube. One of the things I really like about this piece, of course, is that she's got this really complicated input system with its own physical characteristics that color the sound. So for instance, you pluck a spring and it's going to vibrate and then die out over time. And you can see that character, that sort of temporal character ends up in the music, but you also have interactions between the springs. So she's able to get a lot of different music out of this instrument without remapping it. There's also been a lot of interesting projects totally outside the music realm. I'll just highlight a few of my favorites. This was an art project featured in Motherboard. Somebody made this art piece in which you wear a camera on your head. You send the images to Wekinator, and then if it detects that you have a screen in your field of view, like a mobile phone or a TV, it turns your glasses opaque, so you can't view screens when you wear this art piece. This is a really fun interaction made by a student, Caroline Hermans, in one of my workshops. In just an hour or so, she hacked together this little thing. This is called HiBot, and it uses a leap motion, just like I was using with Blowtar. Oops, and so that's all it does. It just waves at you when it detects that you're waving. So this is, probably not a great use of 2 weeks of your programming time, but definitely a good use of an hour or so on a nice relaxing afternoon. A lot of other people have used this. As I mentioned, it's had about 25,000 downloads so far. I don't keep precise track of what people are doing, but occasionally I hear about really cool projects. So for example, Chicks on Speed have used this to make some interesting foot-controlled musical instruments. People have made it, used it to make some interactive puppetry, digital puppetry, where you put up a shadow puppet and the background changes for different puppets. Some interesting startups have been formed. There's a London-based startup called Voclia, which allows you to sing or beatbox into a microphone and then get that rendered as musical tracks. Fair number of projects around building bespoke systems for people with disabilities, and I'll come back to that in a bit. And then just really weird stuff on Twitter, like this guy hacked up an interface to interact with Google Maps. And if you hold up a croissant, it takes you to France. And if you hold up an espresso, it takes you to Italy. And that's like what it does. So there's cool stuff. And again, this hopefully, I've made interacting with sensors a bit easier for more people. All right, now for the other findings. So some of the most interesting things that I've learned after working with and observing users over the last decade is about not necessarily how machine learning makes it easier to make more projects, but about how using machine learning in this way changes or really asks us to reconsider the way we think about machine learning, the way we think about what it's good for, the way we think about how to make it usable, and so on. Starting with this idea of how we think about data. So in a conventional machine learning context, we often talk about data as ground truth, right? Data is this thing that you get, and the truth about the world or the truth about some phenomenon is embedded in that data. And your job as the person applying machine learning is to extract that truth and make it useful somewhere, right? But here, we don't have ground truth, right? There's no ground truth data set of me waving my hand around the sleep motion, right? Or me standing in front of my camera on this stage wearing these clothes. That's a fiction. Instead, I'm using data really just as a way to communicate ideas and my intentions to the computer. So it's a different way of looking at data. Somehow now makes a lot of sense to look at data as not something that's fixed out there in the world, but something that's fungible, something that's temporary, something that's intentional, and so on. And once we start thinking about data in this way, we can think about how this data as an interface for building might be different from other interfaces. So again, oftentimes when people make new instruments or new interactions with sensors, they write those interactions in code of some sort. And that can be great. That's actually perfect for certain types of interaction design, but for others, it's really not. When you want to build an interaction that really captures the nuances of how someone moves or the sound that someone makes, these are things that we as humans have a really hard time explaining to other humans in our native language, much less in math or code, right? If you were aliens from another planet and you landed here and I was trying to explain to you what it meant to wave to a person, I wouldn't write down the equation for how my fingers move in space. I would just say, well, it's this kind of thing. And if you were still unsure, I might give you, other versions of waves, right? That's the natural way for us as humans to express ourselves. Certainly when it comes to embodied activities and often the types of tacit knowledge that we bring to creative work in different domains. So I wasn't looking for this at all, wasn't thinking about this when I began this work, and it started hitting me in the face eventually when I started interviewing composers who were using this to build instruments, and they were saying things like this. I've never been able to work with a musical interface that allowed me to really feel the music as I was playing it and developing it. And of course, as musicians, people building instruments, that's important for us to be thinking musically, to be moving musically, and not always or primarily thinking as programmers. Another really unexpected but important outcome that I learned early on in this work was that this interface, using data as a way to communicate your intentions and communicate furthermore when you might want something slightly different from what the machine has given you, this is a great way to quickly prototype an idea and to explore variations on that idea. And of course, this is super important, not just in musical instrument design or interaction design, but in pretty much any kind of creative field, right? This is well studied that the easier you make it to make a prototype that somebody can evaluate, play with, the better the end result is going to be, whether you measure that in their own satisfaction or the amount of money that you make with the system or whatever it is, right? So this is key in any creative practice. And again, certainly this is not something that machine learning algorithm designers have thought about as important, but here we get really lucky in that just making this process more faster and embodied, a more direct interface can often give us this consequence. Now, something that I continue to be really excited about is the set of possibilities that are now open for relationships between people, whether that's creators or audiences or other people and machines. And so I'll run through some examples, and I've thrown in examples of other people's work in this section, so this isn't just my work. But certainly, in my work, I've observed that using machine learning in this way can change the activity of design, the relationship that you have to your tools as a designer, certainly digital tools. You've transformed it many times into an embodied activity, and often it's a very playful activity. So many of the composers I've worked with have talked about how it's just more fun to play around in the way that I did in the demos. And again, that's one of the things that I like about Wekinator. One of the reasons I sometimes think about it as an instrument, in that this, as a creator, in that moment of creation, you can be expressive through the path of exploration that you take, which I enjoy. A lot of machine learning tools that are out there, machine learning projects in the creative space, use data, not necessarily to give you embodied interactions, but to leverage the very large data sets that are out there now to enhance the realism of some work that somebody does, or enable people to conform to some kind of standard. So we certainly see this in the generative image algorithms like GANs, where you can say, I'm going to create endless new examples from a data set, and they're all going to look sort of like the original examples, but they're not going to be exactly the same. More cats, more piano music, etc. There's some interesting other stuff here too. I don't know if anybody's seen Neural Doodle, but this is sort of a Microsoft Paint-like interface, and you can, paint something and then it'll turn it into something that looks like quote unquote real art. And of course, there's starting to be more and more use cases where people are using generative algorithms to do both creative tasks and other types of tasks. So one good example is morphing and transformations. If we have lots and lots of data, we give it to a type of algorithm. Essentially, we can think about that algorithm as understanding deeply the set of patterns in that data, the set of allowable instances of that data, but also the allowable variations in that data. And we can start doing things like face morphing. So you can say, well, I want to move from one face to another, but I want to stay in the set of feasible faces. So instead of crossfading between two faces, you're traveling through a set of feasible people. Now, I get really excited about this when people start using it in strange ways. So there's Tom White has a nice Twitter feed where he plays around with this smile vector, this idea that you can take an image, any image, and if you have a big enough data set of people who are smiling and not smiling, you can learn about what types of transformations lead a given person to smile. And you can make, all sorts of historical paintings smile, or you can take, photos of very, very serious celebrities and you can animate them and make them smile. So I kind of like that. You can do this in music as well. A few years ago, Google came out with a tool called NSynth, which essentially morphs from one sound to another. And I wouldn't say that a lot of these sounds aren't great sounds, but they're kind of fun. It's fun to play with, kind of like the smile vector, and it might give you interesting new musical material. So here's a few examples. So we're just morphing from organ to electric guitar here. Or we could morph between organ and dog. And so this starts to become a little bit more fun. All right. Another set of tools out there that I enjoy are tools that allow you to fill in detail. So this is called Edges to Cats. And this allows you to do a line drawing of a cat, and it'll fill it in with the most cat-like stuff. And so this is me drawing a cat, and it'll make me a cat-like thing. But what I really like, again, what I like about this is not that this is fulfilling the great, yet unfulfilled need for people to have more cat-like textures in their badly drawn mouse artwork. But that actually, if you go to Google and you start searching for edges to cats, this is what you get. So you get octopus cat, bread cat, Batman cat, and so on. So this, this to me is a great creative use of machine learning. It might not be serious art, but the way that these projects juxtapose human ingenuity and machine creation, I think, are quite delightful. And in fact, a lot of creative work with deep learning, generative learning on the internet, stuff that gets traction looks like this, right? It's not people getting excited about this portrait of Edward Bellamy that's sold at Christie's. It's people doing these kinds of really fun, playful interactions that explore how these algorithms break down. On a more serious side, one of the artists I really enjoy working with generative images in his work is Mario Klingemann. And he talks a lot about how his role as an artist ends up working in making these types of creations here. So instead of working with analog or digital tools to say, essentially what color goes where, he writes a lot of software, and then he uses that software in a sort of Tinder-style interface that he's essentially swiping right or left and saying what he likes and what he doesn't like, and acting more as a curator than anything else immediately before the images that you see in his published work. And then back to Letitia Sanami, when I have asked her about why she uses machine learning in her work, this is one of the things that she says. She says, in a way, you don't want the instrument to perform like a well-trained animal circus. You kind of want it to be a little wild, and you want to adapt to it somehow, like riding a bull. I think the machine learning allowed more of this fun of exploring instead of going, I have to have a result right away. This thing is going to do that, and then leaving it at that. And so in her work, I think this discussion about exploration refers both to the final instrument, right? The instruments that she makes at performance time are a little bit like riding a bull. As you saw in my demo, it's very easy to make instruments that are quite complicated, that leave a little bit of room for surprise. Even if you have some degree of gestural mastery, there might be something new just lurking around a corner somewhere that you end up exploring in performance. But also she, I think, is talking about the act of creation itself, that you're not just sitting down and saying, well, I want this thing to do that, and being in total control and then walking away having exercised your will. Instead, the creation process itself is something that has a lot of give and take in it. All right. The last point I want to make here, this is something that, again, has been really important to my work, and more so in the last few years, is thinking about how this using data to design enables more people to become creators in different domains. And so we saw this already with Neural Doodle. There have been other examples of this in serious software, things like Isotope Neutron Track Assistant, which tries to help novices do good equalization of tracks, for instance, based on how experts have done it. Or maybe you've seen the Bach harmonizer Google Doodle. This allows anybody, no matter what their music theory and music background, to make, compose something in the style of Bach. And it's, music theorists have criticized this for, very good reasons, but a lot of people got to make music that's, sounded in this style for the first time in their lives. And a lot of people talked about it. A lot of people really liked it. But again, a lot of these systems out there really rely on big data sets. Again, we're exploring this this realm of helping novices to conform to a standard. But I don't want to forget this other space where we say, well, let's just use data as this very personal on-the-fly interface. And if we do that, then suddenly designing with data allows things like personalization and flexibility by people who might not be programmers. So I've done a fair amount of work in the last few years with people with disabilities, including one project called Sound Control, which just wrapped up, in which we worked with a music teacher and a music therapist who had a variety of children with different types of special educational needs in their classes. And they were using a Wekinator-like interface to build new musical instruments, to build new musical controllers. And the wonderful thing about this project is that they used the software to go in totally different directions that I hadn't anticipated, and to go in directions that they hadn't even told me at the beginning that they wanted. So just giving them tools to do the kind of on-the-fly instrument interface creation that I showed in the demos allowed them to explore and to answer their own questions about, what might a really interesting, fun, useful interaction be with a particular child at a particular moment. All right, so to wrap up the set of things that I just threw at you in this research section, in summary, machine learning can unlock the creative potential of sensors, can allow people to communicate their ideas and intentions through data, can enable creators to better communicate tacit knowledge and embodied practices, support rapid prototyping and exploration, open up new creative relationships between humans and machines, and enable more people to become creators. On the last 3 or so slides, I just want to throw out some of the questions that I've been exploring currently and recently. They don't necessarily have answers, but they're things that I'm playing with a lot right now that come out of the findings that I just showed you. So one question is, well, great, Y Combinator's done a certain, set of improvements to accessibility for a certain type of machine learning algorithm. What about all this generative stuff? What about edges to cats? And what about, image creation and so on? How do we make machine learning tools that can do those types of things that also allow for playfulness, accessibility, exploration, meaningful interaction, and so on? And again, I don't have a single answer, but one project I'm involved in at the moment is called Mimic, and we are trying to make a set of web-based tools that are accessible for creators, especially in the music and sound space. So hopefully in a year or two, you can go to that website and see something that we can all say, yeah, we solved a little bit of this problem. And we're getting there. We've already solved a little bit. You can go to the site right now, and there's a little bit there. Another thing I've been thinking about a lot is how and what we should teach creative practitioners about machine learning. Because, you can do that demo that I showed you. I could teach you to do that in about 10 minutes. I've taught 8-year-old kids how to do this. It's super easy. But at some point, if you want to make a more complicated system, there's some stuff that's really useful to know about what kinds of algorithms do different types of things, about how to get that, what kind of data do you send to the algorithm in the first place. And the more you know about some machine learning stuff, the easier it is to use it effectively in a very unique practice. So I've had a MOOC for several years now on Cadenze. You can take it if you're interested in learning more. It's called Machine Learning for Musicians and Artists. And I've also been teaching creative students at the undergrad through PhD levels, and people in a lot of arts workshops around the world for the last few years. And unsurprisingly, the big takeaway is that we shouldn't be teaching those people the same type of machine learning knowledge and skills that we would teach a computer science classroom. There's a very different skill set that becomes important, and also a different approach to teaching those skills. For example, we don't want to start with the mathematical equations and prove why an algorithm builds a particular model. There's much more we can do effectively with things like hands-on work, with certain types of examples rooted in practice, and so on. So I've got a paper about that just came out in the autumn in ACM Transactions on Computing Education. Happy, again, to talk about that with you individually. The last question I want to bring up stems from, some of the stuff that's going on in our world right now and recently. I think most people's experiences with machine learning and with data are experiences of disempowerment, of frustration, of feeling like, other people and other, corporations are capitalizing on their data and there's not much that they are seeing in benefit, right? But at the same time, a lot of my work with artists and kids, for that matter, suggests that machine learning doesn't have to be that way. Machine learning can be something that is empowering. It can be something that everyday people can understand, can have a meaningful discussion about. So I'm interested in these questions about how we could make people's other experiences, not just creative experiences, but everyday experiences with data and machine learning, less disempowering. How we could teach people more about data and machine learning, or give them new tools to maybe shape how machine learning is used. And so that's early work. I've been doing some workshopping with some artists in London, and hopefully we'll have more to say about this in the future. So with that, I'm going to end my talk, and thank you very much for your attention. So I don't know if we have time for questions, or a few questions. Any questions? Oh. All right.
Hi, thanks, Rebecca. That was great. So just to you've been talking about all the positive things about using machine learning for artistic purposes, but just to challenge you on, could you say also some of your experiences with problems of using this?
I could give you a whole talk about that. So I'll mention two things. First of all, there are lots of problems that you probably shouldn't use machine learning for. If you think about types of interaction design in which it actually is quite easy to specify something in code or mathematical equation, trying to do that with machine learning can be a real headache, right? So that's a big challenge. Certainly also this question I alluded to at the very end of what kind of data do you actually throw into the machine learning algorithm, especially for people who haven't done much, say, audio processing or video processing or sensor processing. It can be really overwhelming to tackle this, the field of what essentially is feature extraction or feature engineering. And of course, in deep learning, we've solved that in some situations by having lots and lots of data and just getting the machine to figure out what representations to use. But that doesn't always work if we're working with small bespoke data sets that I showed you here. So those are challenges. And then I guess a third challenge that I often encounter with my students is this conceptual challenge. The people come to machine learning, especially in the last few years, and they think it's magic, or they think that it's intelligent. And the types of things that they want to do with it are simply impossible. And it's very hard to sort of redirect people's understanding into the realities of the fact that, yeah, these are not magical algorithms. And in fact, if you believe they're magical, that can bring a whole host of problems, not just as a creator using them, but as, I would say, as a citizen in a world where we're using machine learning for more and more things. And we don't always understand why it's doing what it's doing or what it's capable of. And those are, again, serious conversations that I want to try to encourage in some of the workshopping that I've been doing. I see a question here.
Thanks. First of all, thank you very much. I'm a big fan of what the creative computing community is trying to build in the UK. This is just, I would like to hear your opinion on this. It's something that's really important to me. That is the barrier that defines generative art with a more meta-creative practice. To use, algorithms that have been programmed with some kind of awareness of the world, this evolutionary learning reinforced and whatever. And this, difference of just using generative processes and actually building stuff with an agent. And what's your opinion on that?
So, sorry, what's my opinion? The microphone's gone.
Yeah, just for you to talk a little bit about, or if you have personal work on that. That I'm interested in this duality of generative art and more agent-based communication.
Interesting. Yeah, I guess I don't have a good answer for you because I'm not used to thinking about that as a duality necessarily. I don't see them necessarily as being in conflict with each other, but I'll think about it. I'll maybe give you a better answer tomorrow.
Yes, I can make a question. It might be a bit silly, sorry, but if you can generate so many things with machine learning, there's a risk that people might use it to other things, less interesting, to make a thesis or to make complaints for cops to generate image.
I can think
so do you
of worse
think there's
things
going to
than
be
that
a kind of AI police department, or no? When you get something in your email, how do you know that it was a human writing or the newspaper or not a machine or whatever? So do you have any clues how can we distinguish something that is AI generated?
Yeah, I mean, that's a huge area of research right now. And I think it's possible often at the moment, whether we're talking about text or image or video, but it's becoming harder and harder. And, there are people within the machine learning research community, for instance, who are trying to think about, how might we design an algorithm which at the end of the day makes results which are believable but still distinguishable if we need to prove that something's fake. It's not a solved question. One interesting thing that happened to me was a couple of years ago, I was giving a talk at DeepMind in London, and I raised this question about, what might happen? How can we make machine learning more accessible to wider audiences? Because it is often quite useful in the hands of people who don't have computer science PhDs. And somebody asked the question, or actually just made the comment, I don't want machine learning to be more accessible. We should control who has access to it because it's very powerful and very dangerous. And people are going to, make bots that are increasingly, hard to tell apart from people and so on. And that's certainly one view, but I disagree with that because I don't necessarily trust DeepMind or whatever corporation replaces them to have the interests of the people I work with at heart either. So it's, there's a big set of questions there. I don't have answers to them. However, for me, again, that's one of the reasons that I'm pairing some of my work around machine learning education with, work with artists who are exploring things, issues of equity, for instance, issues of education, not just about the technology, but about wider social issues, whether that's, surveillance or policing or other things. Yeah.
Thanks for the talk. So in my work, I'm extremely fascinated about the idea of surprise and the idea of encountering unforeseenness or unknownness. I was kind of wondering if there's any work within machine learning where there isn't a sort of set data set to train upon, but where perhaps there's machine learning done on something that keeps on changing. So I was kind of wondering if there's some, because a lot of these examples are kind of like, what the inputs are, what the possible outputs are, and the discovery is in sort of the crossfade in between. But I'm kind of interested if there's some work on machine learning where the learned parts, for instance, keeps on changing. Or
sure, yeah, absolutely. So there's a bunch of answers to that. Simply, there's stuff within the machine learning research community itself on something called concept drift, right? Where you want to model something where the underlying process itself is changing over time. And of course, you could very easily apply that to any number of performative uses where you as a performer might go in a different direction in the middle. But also there, I've done work, including musical pieces myself, and a bit of research work where I'm not doing it that seriously and saying, well, the theoretical algorithms that I'm using are tailored to do this and this and this, but to kind of work around simpler algorithms, which are often nice if you have very small data sets, as I often do, and try to reimagine how they might be used for other types of creative ends. So for instance, in the sound control project that I mentioned with kids with disabilities, one of the things that ended up being very important to their teachers and therapists was they wanted to build some instruments where they didn't care so much about the relationship between gesture and sound, but they did care that they made an instrument that somebody could play using the set of physical motions that was comfortable for them, and actually often wanted to build something that was surprising for that kid, because that's fun. And so what we did was super simple, but it worked fine. We took we recorded data from people moving in ways that were comfortable for them. And we just created a fake training set where we mapped a few of those points in that data to random sounds and gave them a model. If they didn't like it, they could hit a button and get a different one. And actually, they really found that useful. So, yeah.
Hi, thank you so much for keeping it a little bit lighter than most of the usual conversation on machine learning now. It was really entertaining. Thanks. I want to expand on this question that came up again. I think two questions came up in terms of binary and duality and problem between what is human and what is machine. And for me, the division is not really as clear. There is a certain division of labor, but whereas human intelligence begins and machine intelligence ends, and whether human errors are somehow better than machine ones, or humans are automatically more ethical and algorithms are evil, these are not given. And I wonder if there is maybe a project or initiative that you can point out to, not just in theory, because Matteo Pasquanelli is doing, there is interesting mapping in terms of continuity between algorithmic and analog thinking, whether there are projects that could take us away from this path that I consider to be almost a diversion of human versus machine, but where we look at quality or soul food, if you will, or fun beyond looking human machine, but actually have a criteria for judging this as a, well, is it good, is it bad, is it honest, is it, but not as is whether it's machine or human.
That's a
And
great
like, where
question.
could we look
Yeah.
for that? Because it's getting a bit exhausting to talk about that.
I think that's a
machine-human.
fantastic question. I don't have an answer. Does anybody else have ideas? Because I know the answer to that. Any suggestions? Yeah.
Just a
Okay.
you know, yeah, but I mean, there's an interesting article regarding arts, not abstract ethics of human ethics, but there's an interesting article on ICEA from two Portuguese authors that is called "Will Mechanic Art Lie Beyond Our Expectations to Understand It?" And the argument is really much machine intelligence will always be different than human intelligence, even if you go deep into cognitive architectures and try to model the brain. That's always going to be different. Yeah, I mean, but that's the argument they give, and I find it really enlightening. Like, it's always going to be different. So, yeah. But sure, regarding ethics, I don't have an answer.
Thank you for a very interesting talk. I really like the whole thought process behind it, the democratization of technology and making these accessible. I was wondering if you had any reflections on what would be the next step, what would be the next 10 years? Obviously, you could imagine, say, a creative collective that would set up. I've made one artistic entity that's a representation of me, and you have 20 more, and they could then basically feed off each other and create like this never-ending stream of multimedial art. The problem right now, as with all machine learning, is that it works best if you have something that's supervised learning, that someone says this is good and this is bad. But it's clear that lurking under the surface, there could be some way that you could almost free this entirely from the human element also, which I personally think would be super interesting. And I just wanted to hear your thoughts on that.
Yeah, that is interesting. So again, I might take it back to the very beginning of my talk where I showed imagining different sources of data. Again, where often, if you want to train a machine learning algorithm to make art, one option is you give it, lots of examples of art. That starts to be really hard when you say, I want something that captures the way that I make art, right? Are you going to be stuck in a room making art for 20 years just to give the training examples to your machine? Like, maybe not. But there are other types of data that you could imagine capturing and modeling, and maybe that's the process by which you interact with Photoshop, or maybe it's combining that with your own top-down ideals for how you might ideally make art if you had the skill, or if you had the time, or if you imagine some sort of cohesive concept running through it, right? There's all sorts of ways that I think might be interesting starting points for that kind of project. Myself, I tend to kind of work one level removed from that and say, okay, if somebody wanted to do this as an art project, or wanted to really deeply explore this space, what kind of tools might we need that aren't out there yet? Because I don't think that that's the sort of thing that's easy to jump into, even to dip your toe into, unless you have, a fairly long, list of software installed on your machine and fairly large data sets and a lot of computational power, and you've got to be really committed to that project to start it. And boy, would it be nice if that weren't the case. So 2 questions back here. Yep. Okay.
to go back to the previous question and discussion of quality in machine learning and so on and so forth. In contemporary composition, this has been a big issue, especially with computer-assisted composition, for a really long time. And a big part of it has become, in a way, to just use it as another tool. It's just something that you'll pop out some harmony or whatever, and then how to show your handiwork or craft or quality as a composer is really how to play around with it in an interesting way instead of just letting the machine learning do everything. So then it becomes really just a partner in your work method. And I do think it's done a lot of creative works that have been original way back in the 80s and early 90s as well. And it opens different possibilities, especially with performance, live performance, even through written composition, so on and so forth. So it's been discussed quite a bit already. And Tristan Murail has written quite a few articles about that way back in the early 90s. And a lot of the other IRCAM composers and Manoury, so on and so forth. So it's been interesting to see it come back in a way from the older discussions, even though it's in a completely different light and with different tools, but it's a lot of the same concepts.
Thanks. That was actually a really good point, and that made me think of one last thing, which maybe I'll end with then, which is again one of the fun things that's come out of the workshops that I've done over the last few years is this idea that or observation that once you start getting your hands dirty with machine learning and actually playing with it, whether that's in music or art or something else, suddenly you have a much more nuanced understanding of these kinds of questions, or even a better criticism of these truisms that get thrown around about machine intelligence versus human intelligence. And you really have to confront the fact that you and the machine are in a complicated relationship, and there isn't a hard line between you, and some of what's exciting is your mistakes and some of it's the machine mistakes. But what is a mistake anyway? And are you influencing the machine, or is it influencing you? And both are happening, and it's just really messy. And that you can't get away from that when you start working with it. And that, again, I think that's something that's healthy to confront people with, because the things that they might assume going into that process kind of fall apart in a nice way. All right, thank you, everybody.
Thank you so much, Rebecca. We will, after this inspiring talk and a very reflective discussion, we'll take 15 minutes to breathe out and get some fresh air until we give the stage to the performers, starting with Daniel. So 15 minutes break. Thank you.
Mathias, er du her? Come on up, man. Mathias Eik, folkens. Woohoo!
Det som er moro er at vi skal spille en låt som man aldri har hørt før. Men vi satser på at han har så godt gehør at han greier det likevel. For det er nemlig testet mange ganger. Han har veldig godt, han har lasergehør. Og vi bare begynner, og så får vi så regner vi at det går bra. Låta heter I Love You So Much That It Hurts. Jeg kan ta forspillet.